We're looking at question 1D of the 2024 test 1 paper. And in this question, we're being given a track which is in motion. So this track is moving. Okay, not a very good artist. So this track is moving, and we know that for a given period of time, and this period is 8.5 seconds, this track has moved from, let's say, position A to position B. And as it was moving, it was slowing down uniformly. So it was decelerating. So now we can take the speed at position A to be the initial speed, and the speed at position B to be the final speed. So we don't know this speed, but we know this speed to be 2.8 meters. Okay. Uh, the distance traveled during this period of 8.5 seconds, we are told to say it's 40 meters. Interesting. Now, and the time taken for us to move these 40 meters, we know that this time t is 8.5 seconds. So now we're being asked to find the original speed, or to say the initial speed at which the track was moving before it started slowing down. So to do that, we're going to employ two simple formulas. Our first formula will be S is equal to UT plus 1 over 2 AT. And our second formula will be final velocity is equal to the initial velocity plus the multiplication of the acceleration times the time. Okay, these are the two formulas we're going to employ. Another thing that we'll notice is that we haven't been given the acceleration. So what I'm going to do is we're going to manipulate this formula to make the acceleration subject of the formula and then replace it here. So let's quickly do that. If we do that, we find that we will have our acceleration A to be equal to the final velocity minus the initial velocity over time. So now replacing that in our first equation, what we're getting is V minus U over T. Actually forgot a squared here. There's supposed to be a T, supposed to be a T squared. All right. So once we do that, we'll notice that this T can cancel with one of the T's here since there are two, and we just remain with one T. And another thing that I can do here is that I can multiply throughout by 2 so that it rid of these 2. Okay, and if I do that, what I'm going to get is 2s is equal to 2 ut then minus vt, since I'm multiplying throughout this t which is outside, it's supposed to be a plus here, minus ut, like that. And this one can cancel with one of these. Okay, and what we're remaining with is this 2s is equal to vt plus ut, and we're finding the original speed, which is the initial. So we can manipulate this formula again so that we can only remain with u. And if we manipulate this formula, we find that what we're going to get will be u is equal to 2s minus vt over t, like that. Now we can actually simplify it a little bit further by cancelling out this t, k, and we'll just have a t here. Yes, and simple terms it will be like this: us over t minus v, like that. Replacing in this the values that we have, we know that s is equal to 40, our t is equal to 8.5, minus our v, which is the velocity at point B, is equal to 2.8 meters per second. Once we carry out that calculation, we find that we have 9.41 minus 2.8. This will give us a final value of 6.61 meters per second as our original speed before we started slowing down. And that's how you go about solving this question. As I always say, simple and straightforward.